Watching. It is April, well, it's April 1st here, 2026. I'm working more on my stock market project in Python. I want to make a quantitative model to generate returns in the stock market. So first I'll go over my goals for the project. I'll go over what I've done so far. I made a pretty key finding this morning in the stream. So I'm going to go over that and then talk about what I'm going to be doing today. So if you're interested in stock market models, markets in general, machine learning, Python, AI coding, or anything similar, subscribe, follow along. And that's what I'm interested in. I do this project every day. So yeah, you can subscribe to follow along. So these are my two goals for the project. First goal, I want to beat the S&P 500 by a significant margin and make money in all regimes. So if the market's going up, I want to be doing significantly better than the S&P, 2 or 3 times as good. But if the market's going down like it is right now, I want to still be making money. So make money no matter what and do way better than the market average. Now I'm writing all of this code in Python, so my second goal is to generalize this code into a tool that anyone can use to make models for themselves without having to be proficient in coding. So this is kind of the outline for the model. First, we have the stock universe. So you have data for the model, but you don't want to just send all data into the model. Not all tickers are going to work well. Certain things like test tickers for the NASDAQ, those are going to mess up your data because they never change in price. You don't want things like penny stocks. You don't want things that are low volume stocks because there's going to be a lot of slippage in low volume stocks. The price action is different. Price action is different on ETFs, so you don't want anything like that in your model. Once you've isolated a good universe, you want to feed that into a model which will generate predictions for the returns. So I'm predicting things like returns for the day, returns for the next 5 days, variable time period forward, 10 days, 20 days, probability of going up, returns normalized to the market, so returns minus the average market returns, things like that. And then once I have a good returns model, I'm going to be incorporating it into this portfolio model, which is going to basically adjust positions according to the output of the model. So I started this at the beginning of the year. Here's where I was at the end of January. Basically, the model was too fragile to implement with real money. Before I could go through and find a better model, I had to basically clean up the code base. So I made diverse classes to do everything, and this was a much better, way of training the model. Much better organization for the code base. Everything's now flexible, so when I want to add something like a new filter for the universe or a new feature for the model, it's really easy. All I have to do is write a few lines. I don't need to go through and restructure everything. Not like before where I needed to write a new file for every step of the model. So these are all the features and targets that I implemented. Once I had these, I was ready to go on the model. And so, again, this year took January, so this is where I was at the end of January. By the end of February, I had finished cleaning up the code base. And over March, I was looking into the model, changing around the model, trying different things. I found what I initially thought was a really good model here. I went through and tested it a bunch. After all the tests, I was really confident in my model. What else? But then I did a walk forward analysis, and I found that this model performance is actually degrading with time. I tried incorporating new things into the model, wrote a bunch of code to incorporate sectors into the model so I could neutralize to the sector instead of the market as a whole. And it turns out you only want to do this for mean reversion and volatility features. When I did this, I found a nice improvement to the model, and I found even more of an improvement when I used NAICS, so North American Classification System, the sectors from there instead of sectors from the SEC Edgar database, which give SIC codes. That's really outdated. That's from 1930. So that doesn't work as well. This North American industrial classification system is a lot more modern. So once I had this, okay, I thought this model's performing better than the previous model. Let me do a walk forward analysis like I did here. But as you can see here, not only is it giving negative information coefficient for some years, it doesn't finish running, so it only goes through 2020. So I had to go through and figure out what is the problem here. And that's what I was doing this morning, and I found out the problem. So the problem is that I'm isolating the universe. So, stocks are coming into the universe if they're meeting the criteria, and then they're being dropped out of the universe if they don't meet the criteria. Now, what this means is that the way that I'm calculating features is I pass at the universe data frame, and then I'm calculating the features. So for lag features, like where I'm looking back over the previous 200 days, moving average over the last 200 days, this isn't going to work because I don't have all of the price data in the model. So it will only work on stocks which have, for instance, the 200-day moving average. That's only going to be in the model if if the stock has been in the model in the universe for 200 days. If it hasn't been in the universe for 200 days, it will still calculate the feature, but the feature will be wrong. So what I'm going to do today is write some code that's gonna basically implement it. The feature generation should happen on the whole data set. And then the universe that I give it should trim it down from there. So that's what I was working on this morning. I had to go to work, so I'm back at it tonight. So let's see how far we could get. I'm hoping tonight I could implement all of the features I want. And then I can rerun these models with this new strategy, which incorporates features the correct way instead of the wrong way. So that's what I'm working on tonight. So this is stuff from work. Okay, the first principle solution to calculate a 200-day moving average for a stock that enters your universe on January 1st, 2020. You don't need the entire stock market's history. What you need, you only need that specific stock's contiguous history starting 200 days prior to January 1st, 2020. Here's the architecture to fix your model class. Okay, I don't want this to happen inside of the model class. Rather, it should happen inside of feature engine. Critique this strategy. Oh yeah, I should also say, so like I said, all this is on GitHub. So of course subscribe, but also go to the GitHub, download this, try it out for yourself. Got it. Agent mode. Yeah, try it out for yourself. And let me know how it works. Don't do that until I finish implementing this correction because it's not working correctly right now and you're not going to be able to accurately train models or reliably train models. But once I've implemented this, please try downloading this. Let me know how it works. Let me know what I can add. And it helps me out a lot if you star the repository, watch the repository, and follow me on GitHub. That helps raise my coding profile, helps me get coding jobs and freelance gigs. Okay, so this should happen inside of feature engine. Critique the strategy if there are any issues with it. If not, develop a method for reading in OHLCV inside of feature engine and calculating the features efficiently. I still want to pass in the universe data frame. However, I only need the symbols and date columns of the data frame which, all right, so let's pull up Python. Let me remind myself of what should that look like. So Python 3, import pandas as PD, and let's pull the data. So df is equal to pd dot read feather, and let's read dot slash universes slash universe 7 dot feather. Universes, and it's just actually called 7 dot feather. Okay, we need to go to data dot slash data slash this guy. All right, then df, and so which are named date and account symbol respectively. Adjust the model class so that it drops the unnecessary columns from the data frame. What else? The feature engine should read in the universe, and the feature engine should read in the universe at I think it's compute, I called it. Feature engine, not here, scripts, feature engine, should read in the universe at compute as df, which it already does. Compute should have an additional argument passed in, which gives the file path to the full data as a feather file. This should default to dot slash data slash all ohlcv dot feather. Reason from first principles and prioritize efficiency and elegance in the solution you give. Okay, so very good. Now let's see what solution we get out of this. Yeah, nobody's watching right now, so I'm just going to put in music until somebody tunes in. The critique, reasoning from first principles. Your strategy to move the raw data into the feature engine is an excellent architectural decision, but it comes with one specific risk that we must engineer around. The model class should only care about which features it wants and when it wants them. It should not be responsible for calculating look-back windows. Yes, exactly. By passing a universe mask to the feature engine, you turn the engine into a black box that fulfills requests perfectly. Immutability of the mask. The universe mask guarantees that no matter what crazy look-back windows or data transformations happen inside the engine, the output perfectly aligns with your trading universe. The risk. Memory trap. Okay, so why don't give the entire new code. Just tell me what to change and where. So all OHLCV after loading all OHLCV.feather, we can drop out unnecessary rows. Would this be efficient enough to avoid the RAM explosion? Recommend me some songs if you have any ideas, one viewer. If you use pd.readFeather, pandas will load 100% onto the RAM. 20 to 30 gigs of RAM. Because Feather is an Apache Arrow format, you can do that easily. Right before you initialize and run the feature engine, strip self.data down to just the columns you need for the universe mask. Is this going to work? What, buddy? Where are you? Okay. Okay, so first let me update any changes I already have. Added debugger when walk forward fails. Okay. Added logic for fundamental features to model. added has fundamental feature and removed look ahead bias. Okay, now we're ready to start adding these changes. So first change. Adjusting the model class. So we'll do calls.keep. Feature engine is equal to feature engine. Price requests. All right, so let's look at the code. We want clean analysis first. Clean scripts. Clean analysis. Let's put it next to feature engine. All right, and we can make this guy a little bit smaller. Make this guy a little bit bigger. Okay, good to go. Let me put a song on. Okay. My phone case is literally falling apart. Look at this. I need a new phone case. All right, so generate targets and features. Price requests, fundamental requests, create the universe mask. Cleanup, drop NA logic. Feature engine. So where do I call feature engine in here? Generate targets and features. Overwrite self.data to be just the mask. Get the feature engine. And then we do feature engine.compute. Okay, so let's do this. Drop price calls from data. These are not needed because prices are calculated inside of feature engine. Call for call in data.columns. Okay, so if we've already calculated some features, let's keep those. feature engine equals that. Then self.data is feature engine.compute, and first we're going to pass in self.data, and we'll leave the rest, we'll leave that just as is, because now inside of feature engine we're going to implement the other stuff. So in compute, determine the maximum look back and forward shifts needed. Oh, here we go. GC, do we already have that? Yep. So let's just import this guy. Feature engine. Max look back, max forward. Okay, so let's add this argument into the initialization. Oh, sorry, into the compute phase. Let's add this description. Oh. Okay, I'll do that print statement because I like it. It looks nice. Now let's add in phase 0. Now just give me what to change. Is this Gemini Pro? Yeah. Change the compute method. Put that back in. Now what is the safety sort? If not, df.attributes.get is sorted false. df equals df.sort values, account symbol date. So the safety sort should happen after. Okay, so where should the safety sort go? Before or after phase 0? will these changes still work? Hey, NGK. um, yeah. Um, I'm not even on buy and sell. It's just looking at if you have the log returns for the day. So this is what log returns look like. So ignore the versus SPY baseline. The blue is what I'm looking at. So you can calculate the log returns for the day. You can do the close of the current day divided by the close of the previous day and take the log of that. And that's powerful because it's going to be the same, basically stationary for all stocks. Even if, say, Apple is $300, if that moves up to $330, the log return is going to be 330 divided by 300. So, what is that? 10%? Yeah, the 10%. Yeah, it would have made a 10% gain, and then it's the log of 0.1. And so similarly, the returns for like a smaller price, basically what it does is normalize the data so that you can compare apples to apples instead of if you're not doing log returns, you have the problem of, these two stocks are different prices. How do I compare them? So log returns basically makes it so that you can compare the stocks for each other. And what I'm predicting is the log returns for the day. And how I'm doing this is using basically all sorts of different features. Currently, only features on the price data. I also have fundamental features, but this is like what some of those look like. So here you have the log returns. I think this is for Apple. Yeah. So here you see how the Apple price is changing. Starts at 300, goes up to 320, drops down to about just above 220. And so if you want to compare this to another stock, that's going to be hard. Rather than that, you can compare like these features. So I'm giving it things like the Bollinger Bands. What's the distance from the Bollinger Band to the price? And so you're using all sorts of features like this thing right here. Or that's what the model's taking in as its information. So I know information like this, and then you have all of these features. So those ones are actually broken. But here's some of them. So you see in white how the price data is changing, and then you see in the interesting sort of neon looking colors what the values of the feature are. So it's getting those values of the features, and then it's trying to predict what are the log returns going to be either for the day or The models that I'm currently training are trying to predict 5 days out into the future. What's going to be the returns for the next 5 days if I give it all of these different features. And so I need to go through and figure out basically what features are useful to give it, what targets perform best, what combinations of features and targets give it the best model. Give the best model. And then once I have a good model, I'm going to be updating it every day, and that's just going to be spitting out predictions. And then there's going to be a larger model on top of that, which takes the output of this returns model, and it's going to say, okay, I know basically the predicted return for this stock. I know the basically how the S&P 500 is doing. I know the trend of the market. I know stuff like interest rates. And based on all of this information together, I'm going to take all this, synthesize this, and then tell you how to allocate your portfolio for the day. But before I get to that stage, I'm focusing on predicting the returns for the day. So I need to generate a model that's not only powerful in predicting, but something that's really stable. It's not, its worst predictions are never too bad, and on average, it's beating the market. Beating a coin flip, basically. That's what I'm going for. And to do that, you need good data, so you don't want to use all the data that you have. You want to isolate some useful stocks to look at, which is what I'm doing. That's called a universe. You have a universe of stocks. And so recently, though, this morning, I ran into this problem. So you can do a basic analysis of a model, just split it once into test data that you test on, training data to train the model and get the model basically how it works, and then you test the model on this test set to see, okay, I've trained the model. You can't test the model on the same data that you train it on because that's going to be biased. You've already trained it. You want to say, like for instance, if I want to start a model from today, I'll train it on all data that's previously happened in the stock market, and then I can test it on tomorrow. How does it perform on tomorrow? When you're building the model, you want to use a bigger test set. So I'll say something like, train on 2011 to 2020, and then test on 2021 through 2025. And then if the test is working really well, I know I have a good model. And an even more efficient way to do that is train a bunch of models. So here I'm grouping it into the models, and the data is grouped into years of 6. So the first 4 years are the training data for the model. The model has a bunch of hyperparameters, so things that control how the model learns. Like these are things like learning rate. This is a tree-based model. You can look it up, but it basically looks like a tree coming down. There are a bunch of leaves coming off, and it makes decisions. Each leaf is making a decision on how to get the output. So the hyperparameters, so for the 5th year of the group is for training the hyperparameters, and the last year of the group is for testing the model. So if you have a really good model, every year, every group that you go through will give really good performance on the test year. And then this morning, I figured out basically, so I did this on this model, but then my question was, okay, if I try to do the walk forward, I found a better model here. On the right, this one's performing really well. And so I said, okay, I'm going to do a walk forward on that, train a bunch of models and test them sequentially year by year and see if the performance is good. So this is a much more restricted universe because earlier I wasn't restricting the universe much. I was using way too many stocks in my universe. So once I trimmed the universe down and then tried to do the walk forward analysis on this really good model, I found that it ends in 2020. And so I was digging into this. Not only does it end in 2020, but it looked like it was doing well when I just trained one model. But then when I break it into a bunch of different models and test it sequentially, it seems like it's breaking down. So the IC, I'm shooting for a target of 0.01 to 0.02. And so you see it goes negative in 18 and 19. That should never happen. If the information coefficient is negative. That means if you predicted the opposite of what the model's predicting, then you would be doing better than a coin flip. And so that's a sign that your model is extremely bad. So this morning on my stream, I was digging into this, why is this happening? And I found out the problem was I was only training the features I was getting the features from my universe data, not all data. So the way the universe is defined, it updates every single month. So you put in filters, like a very simple filter would be, get me the top 1,000 stocks by volume for this month. And so it'll give you the top 1,000 highest volume stocks. So obviously some months, the top 1,000 highest volume stocks aren't going to be the same for every month. So some months, there will be stocks that come into the universe every month, and stocks that get dropped out of the universe every month. So when I was calculating the features only on the universe data, there was certain data that was missing. So if you imagine, say Apple was in their stock universe for January of this year, and then February of this year it dropped out of the stock universe, and then March it was added back in. Some of the features I'm calculating, an example of a feature I'm calculating is the 60-day moving average. And so rather than just take the price or the log return, you can get the moving average of the log return. How's it change over time? And so when you're doing that in this scenario where Apple didn't exist in the data in February, if right now on April 1st I wanted to get the 60-day moving average, that would go back to about the end of January. But since the data didn't exist in the model in February, the 60-day moving average is actually going back to the end of December. So basically the model isn't working well, and what's happening here, the reason it's not getting anything is since I'm using a much more restrictive universe and I'm normalizing to sector. There are some features, basically the model doesn't see any data past 2020 because the universe is so restrictive that it's not able to calculate the features going back 60 days. So that's the problem with how this is working. So what I'm doing right now is I'm trying to update it. So I have the universe, but I don't want to calculate the features on the universe. I want to calculate the features on all of the price data that I have. So that's basically what I'm doing. Let me know if that made sense. I was kind of rambling. I hope that made at least a little bit of sense. But right now I'm going through the code and trying to update it so that it will get the features from the entirety of the price data, not just the universe data. And that's what this is supposed to do. So this should all go in before phase 1. And then this is changing. So this is input df, is what it's called here. Basically, I've written all this code so that I pass in the universe as df here. So this wasn't called input. Just now it was called df. I didn't have this argument, so this is what the function looked like. I could comment that out. Yeah, so that's what the function looked like. Just you pass in a data frame. And the data frame that I was passing in was the universe. So since I don't want to do that anymore, I want to pass in this raw data path so that it can pull the raw data, get all of the price data, and then calculate the features based on the entirety of the price data, not just the universe. The problem is lower down, all of the code is referencing the first argument I had here, just df. So I don't want to reference df anymore. That's the universe. I don't want to be calculating the features on df. I want to use this path to all the data, and then calculate pull that data set and then calculate the universe features from that data set. Sorry, I'm spitting. And then add it back into the universe. Yeah, so let me know if that makes sense, or if it doesn't, yeah, ask a question about it and I can elaborate more. I'm kind of tired. I have a long commute to work, so I left for work today at 9 a.m. I got back from work at like 9:30 p.m. So my brain's kind of cooked. I'm not explaining things well, but I hope that makes a little bit of sense. All right, now this guy I want to get rid of. Phase 1 global calculations. Okay. The problem is okay, so that's phase 1. So we could take out this, and now let's add in this stuff that should happen before phase 1. This is basically the annoying work that I have to do. But that's okay. This is the annoying work. The idea is, since I'm organizing all of this code and putting it in a GitHub, I want to make it so that nobody else has to do this annoying work. They could just have, a code base that works and create models for themselves. So this serves two purposes. It'll help me actually get a good model, and it'll help other people so they don't have to do this cumbersome, boring work. Okay, so we load in the data, then we say raw df is this guy, then get the df. Okay, then we have the rest of the code for getting the features, and then right before we return it, we want to merge the features into the data frame. So merge them in, and then I'll return the data frame. Now all the code that I wrote for the model should work uninterrupted, because all of this is happening inside of feature engine. The model calls feature engine.compute, and then we should be good. So inside of here, it's calling feature engine.compute. Where is that? Oh, yeah, so feature engine, I'm defining the feature engine. I don't need to change this at all. And then when I do this compute, I don't need to change that. So everything should be happening inside of feature engine. Are you going to bed? Yeah. The dog seems to want something. Who? Oh, Buddy? Yeah, he came out. I wonder what. That means he wants you to do it. He says if I go with Pat, it's no good. No, he needs to go with his Pat. Oh. I'm going to bed. Nighty night. Night, sweetie. See you then. Okay, so, hey man, thank you. I appreciate it. I hope that makes sense. Okay, so now we have that. Supposedly that should work. So let's test that on, let's go to model. Okay, so we can make this guy full screen again. Let's go to Model Explorer. Did it make sense? Not really. But I assure you, I think it might be both of us. I have a simple mind. Well, that's a good thing in a lot of ways. Gave me a base to build an understanding off of, though. I will come up with a question. Well, I really think I didn't explain things too great, because honestly, my brain is cooked from a long day. I had to think a bunch at work. I didn't sleep well last night. It's just going to be a long week at work for me. And then next week I have to travel and go to Colorado for work. And then, yeah, every day is going to be a long day for the next 3 weeks. So, I just need to work on this. My idea is if I just hit my head into the wall every day, eventually a good model will pop out. Okay, so let's run this test. So this is the test I was doing this morning to see if it was computing things correctly. So let's do that test again. And we could run it. We need to deactivate this. and activate my other conda environment. Conda activate stock dash market. Okay, now let's run Model Explorer. And the idea is that you guys should be able to download the code and basically write 50 lines of Python code. You don't need to write it. You could use AI like I'm using right here and just say, you know, try out this sort of universe. Basically, you don't need to be coding. You need to understand, you know, read about features and stuff and understand what's going on. What kind of model do I want to make? What's going to be effective? And if you watch the streams, I go through literally everything that I'm doing. So if I get a really good model, you can just watch the streams and copy my strategy and get a successful model. Okay, so let's make window 60 days. And let's run this again. Okay, you know what? I could actually just run model 18. Or let's go back to model 12. Because that's a little bit simpler. And actually we could do something even simpler. So, using ranked features, regression target with... Okay, so let's do model 3 because that should be faster. And let's see how that performs. And then did I document model 3 performance? This would have been a long time ago, probably like 3 or 4 weeks ago. So model 3. 4 best features. This is before I added all the different tests and metrics. But basically I want to make sure feature engine doesn't break. So invalid file path or buffer object type. So error in model. Oh, because this is outdated. So let's actually, yeah, this is too outdated. So let's go back to model 12. This is from several versions ago. So let's just run model 12. This is the first good model that I had going. So let's see how this guy does. Okay, so there's an error. Model.split data. Feature engine.compute. Self.data. Line 759 in compute. Okay, so let's say why do I get this error when I try to run my model? Here is the output. Okay, so it's 11:08 right now. I have like, I want to be done by midnight, so really my rate limit. Psh, seriously, that sucks. How do I view when my rate limit refreshes? When do I get new requests on Google AI Studio? Reset at midnight Pacific time. So in 50 minutes when I want to end the stream. Okay, that's fine. So let's go to Claude. I should have more requests there. Here are the files I'm using to create a useful stock market model. So you get some log return value prediction for 5 days out, and that signifies some plus or minus volatility incoming. Get a log return value prediction for 5 days out. Yes, that's the output of my model, and that signifies. It doesn't say anything about volatility, although volatility should kind of be something. Basically, the model is giving. Here's a prediction for the return value, which you could walk that back through. Here's what the value should be. But yeah, if it's a positive log return, it should go up over the next 5 days. If it's a negative log return, it's predicting it's going to go down over the next 5 days. That negative value, yeah, that's right, but it's not. Yeah, that's basically right. It's just not volatility. It's not predicting volatility. It's I guess how is volatility defined? It's predicting some movement, basically, up or down movement. And that's the first step. If I get a model, that's kind of like the hard part, is getting a model that's reliably predicts up or down movement. So here are the files I'm using to create a useful stock market model. Clean analysis contains the model class, feature engine .py, clean analysis .py. Feature engine .py contains the it's predicting the move in price. Feature engine .py generates the features for the model. So this is like the basic layout, is you put some features into the model. You could just use the price data as features, but it's not going to calculate. It's not going to be a good model with that. So you want to say, here's some features, some like more advanced features. Here's the target, 5-day forward log returns. And then also I'm normalizing the target. So to the market. So you don't want to, better than predicting what is going to be just the log return, you can predict how many standard deviations is the log return of this stock going to be away from the average of the market. So since if the universe is getting, say, 1,000 stocks every month, you want to say, if I take all the log returns of the month and get a distribution, how many standard deviations away is this log return from the average? So if something's like 2 standard deviations away from the average log return, that's a strong indicator that that stock's going to go up. And then the portfolio level is taking into account these macro things. Okay, the whole market's going down really bad, maybe 2 standard deviations above. Sure, the model's predicting that, but let's not put too much money into that, because that's a little bit risky right now. So feature engine.py contains code for generating features. Below is the pasted. Below I've pasted the code I'm using to run the model. Why do I get this error? Pasted below the code for the model. Okay, so first let's give it the files. So we want to give it clean analysis, scripts, clean analysis. We want to give it feature engine. Okay, now let's paste the code I'm running. So this is universe 12 or model 12. Okay, now let's give it the error. And let's ask it to think. So this is why this is like the best, most useful thing about AI coding is, it'll give you some suggestion for, here's how to, solve the problem you're trying to solve. You get error, you can just feed it the error and say, why do I get this? It'll look through the code and tell you why. It's nice, easy. NGK, do you pay attention to the stock market? Were you paying attention to Trump's announcement? I'm big on earlier this month on like March. Let's see, it was the week before March 14th. It was around March 11th. I sold everything in my portfolio and I'm sitting on half my portfolio is cash, half my portfolio is USO, which basically is a ETF that holds oil futures. And my bet, I kept looking at the war and I went, I don't see any way the Strait of Hormuz opens. And each side in the war, Iran, their main leverage is keeping the Strait of Hormuz closed and destroying oil facilities in the Gulf countries. America's main leverage is destroying oil facilities in Iran. So it seemed like I didn't see any way that the war was going to end soon. Oh, nice. So what strategies do you use? Do you my coworker tells me to look at stuff like he basically does that thing where you look at candles and you find some price level where there's resistance, and then he has like stocks he likes, and then he watches to see if if it breaks through the resistance, then he buys, or if it drops below resistance, he sells. He uses all these complicated things like covered calls and stuff. Date time conversion. Good. All right, so do it after sort values in feature engine. Anyway, I'm excited about that because I was thinking, all this talk so far this week was about, the war's gonna end. And I went, no, I still don't see any way the war's gonna end. I don't see how Trump could get a win out of it. I don't see any reason why Iran would end the war. So I think it's gonna keep going. So sure enough, it's going. So let's find that line, raw df dot sort values, and then below that, whoop, not that. We want to put this guy. Paste it in. Now let's run that. See if we get the error still, or does it start running? Does it pull the features? So yeah, the first thing I do is you can kind of see the structure here. So I'm these are all kind of working the same, but so I generate the features. These are all the features. Put them into a list. These are all requests, so it's not calculating anything yet. Then you make the model. You basically give it these paths to where should it find the universe data and where should it save the output of the model. Then you just add features, you add target, and then when you do train model, it's train model. I'm not splitting data. Oh, so that's working wrong. Here, you add features, add target, then you split the data. That's telling you, here's the test data, validation data, train data. Then you're training the model. And so in here, inside of split data, once it splits it, it also gets the data and gets the features. And it's using all the logic that I have here inside of feature engine. So I'm running this. It wasn't working. Now I'm rerunning it with this fix inside of feature engine. And let's see if it works. So this is what I'm running, model 12. It's taking quite some time to compute because now it needs to load in all data. So I could let it do this for a little bit. Let's see how long it takes. So we'll give it let's make a timer. Anyway, you trade every day. What's your strategy? Tell me what your strategy is. Let's give it 5 minutes. Feature engine is taking a really long time to compute. How can I speed this up? Okay, so it computed the features. More or less, yeah. All boils down to horizontal lines. All I need is OHLC and volume profile, volume by price. Oh yeah, that's exactly what my coworker does. He does the same thing. He's looking at volume and yeah, so if there's a, tell me if I'm reading this right. What do you use? Trading view? I call pivot points between zones of balance that I can scalp from. So I'm almost positive that's the same thing my coworker does. You should make a YouTube channel, or I guess you have a YouTube channel if you have a YouTube account. I already signed up, man. Why am I not signed in? That's bright. Continue. Okay, I'll create a new one. That's good. That's a good place to be. Oh my god. No, I'm not paying for anything. Yeah, so if you look at this, basically what you're doing is, this is way too much. And then we could make it, let's look at, because you're using, do you use daily candles or are you using, like minute candles? One day. I guess it won't give me minute candles if I pay, but okay, so let's look for a spike in volume. So here's a spike in volume. Right here. So we could say that's resistance. And you would do something like, how do you draw a line here? You would do something like, you know, there's this spike in selling volume comes, you know, right here. So you find the resistance is here. Then here's a big spike. You find the resistance went lower here. And so then you would sell, right? And then that would work well because then it goes down. So next spike, big spike is here. And you see it's a spike in selling and it encountered price resistance here. And ideally that would be similar to some price resistance back here. And then you say, okay, so this, if it drops down to this point, I'm watching it. I don't know what I'm doing really. This stuff kind of confuses me. And I always get lost on this. I never know how to feel like it's reliable. Look, so this worked. So let's see. We already have the performance of Model 12 from earlier. Let's see, does Model 12 improve when I'm calculating the features correctly? Whoa. Negative information coefficient. So that's important. I need to put that into my PowerPoint. This looks terrible. Look at the long short. Well, at least it ended up positive, but that looks pretty bad. The model returned negative IC. This is significantly bad performance. Look at feature engine. Do I have a logic error in how? So even if the model is useless, it should just have an IC that's approaching 0. If it's negative, then you know, you could just bet against the model and do better than a coin flip. Do I have a logic error in how I'm getting the features and incorporating them into the universe? Okay, so let's document this. Model 12. Okay, so let's put this guy up here. Actually, let's undo that and then just move this guy down here. Model 12 performs significantly worse with new feature. Most likely all of those peaks you just showed rejected off of a zone that the market had previously moved through very quickly and left little order volume. A fair value gap somewhere where price doesn't want to be. A pivot between balances. This stuff all confuses me. Now you're confusing me. Rejected off a zone that the market had previously moved through very quickly and left little order volume. A fair value gap somewhere where price doesn't want to be. A pivot between balances. Yeah, I think my brain's too cooked to understand what that means. Model 12 performs significantly worse. Anyway, do you have any good recommendations for books that I can use to figure out how to do that sort of trading? Because that's what I really need, is a book I can read through. Yeah, so at least the Sharpe ratio is positive, but the information coefficient is negative, and it's really negative. Like, this should look like a staircase, and it should start low. Okay, so that bar looks good, and then it should look like this, where it starts low, gets higher, 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 with every decile. Here it starts low, but then it goes high. It looks like a good staircase. If it looks like a good inverse staircase if you just remove that first bar. Actually, the absolute value is good. So if I just inversed this model, it would perform pretty well. Yeah, the information coefficient to information ratio is good. Literally everything's just negative. So why is that? Why is it doing so poorly? Like if I just inversed this if I cut out this decile and inversed this model, it would do really well. So there's some information in there. You know, if an inverse model is doing really well, then I should be able to figure out, why is it doing like inverse? That is befuddling. This thing's taking forever to think. Let's see if I can find it in the code. So the neutralization, yeah, I guess should be to the rest of the market. Yeah. So there's something wrong in this logic. I know there must be. But this stuff's all the same. So where's it merging? It's merging again down at the bottom. Merge universe mask df on date account symbol how inner. Look at the relevant code and feature engine. Okay, the error is straightforward. Your date column isn't being recognized as a date. Oh, okay. We're back to down here. Still thinking. I don't know. I hope I can figure this out tonight. I'm gonna go get a Dr. Pepper real quick. A book. No, but in general, I'm trading ICT principles. Tons of content out there. You're just looking for the market structure and trading from level to level. So, ICT principles, it's called. Well, I could look at that while this guy's thinking. Inner circle trader principles are a trading methodology focusing on mapping smart money, such as liquidity grabs, fair value gaps, and order blocks. Fair value gaps to predict market reversals and trends. Yeah, so whatever the institutions are doing, those are high probability setups. I mean, that makes sense. The whole thing's about beating institutions. That's what's exciting. I was talking to one of my coworkers today, and I said, "Oh, do you like me and the one guy I work with? Like all day, we love the stock market. So we're always talking about the stock market." So I was talking to my other coworker. I said, "Hey, do you like the stock market?" He said, "No, but I could tell you guys are really into it." Um, and I said, "Oh, why don't you like it?" He says, "Oh, well, the institutions, they make money and they make money off people like me." And it's like, yeah, anyone who's, tried to make money, I think the journey kind of is the same for everyone, right? Like, I started almost 10 years ago now. I started summer 2017. I got some money to invest in the stock market. Um, and I just did really stupid things. I just said, "Oh, I like this company. I'm going to buy it." And I lost a bunch of money. And so that's how most people feel is we're just, the institutions just steal our money. But the whole exciting thing is stuff like this, beating the institutions. Mastering ICT concepts, the ultimate trading strategy guide. A lot of people are drawn to ICT trading concepts because they offer deep understanding of blah, 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 fair value gaps. So this is what you're talking about. Represents a price imbalance created when the market moves rapidly in one direction, leaving a gap between consecutive candlesticks. This gap signals inefficient pricing, which the market tends to revisit later to balance liquidity. Spot a fair value gap when there is a 3 candlestick formation. So, okay, so this is a fair value gap, but why? I don't want to lose everything that I already gave that because I'm going to get new requests at midnight. So if I'm still going at midnight, I'm just going to use that same thing and just say, fix it for me. Because this guy's still thinking, holy shit, Claude just thinks forever. Map it out for me. Anyway, NGK, you should stream this. If you've been doing it a while, you know all sorts of things that people would like watching. At its core, okay, so what is actually happening? Financial markets operate on a continuous system. Yeah. In a massive upward move, there are only buyers and no sellers. And the inverse is true as well. This creates a price inefficiency or an imbalance. Yeah, because buyers and sellers aren't fighting it out. The FVG is the little gap left behind on the chart where only one side of the market participated. Because the market algorithm is designed to be efficient, price is highly likely to return to this gap later to rebalance the books. Before continuing in its original direction. So here's high volume where everyone was buying. But the price I guess the price moved in between the candlesticks. Oh, this is all after the market closed though, right? So we got to go to 4 p.m. So 1600. Okay, so we're getting ready for market close. Imagine prices consolidating between $5 to $7 for 2 days, then rapidly jumps up and consolidates from $10 to $12 for 2 days. $8 to $9 was a gap where the market found the price to be a fair value. Yeah, so when you see it jump up, but then how do you know that it's not going to just stay? How do you know $10 to $12 isn't the value? It's because so the market should go back and test $8 to $9, but how do you know it won't just blow through that? Or you can reliably count on there being a pullback to test the $8 to $9 level again? This is crazy. Why is this taking so long? Maybe if I stay on this page and become a zone of interest. So $8 to $9 becomes a zone of interest. You want to watch $8 to $9. Is that what you're saying? $8 to $9 would be the zone of interest there. And then you want to watch $8 to $9 to see what happens. Well, any levels can be looked at as a pivot of a brick wall it can't pass. ES, okay. I'll go there. You mean for today or just something like a wait, so what do you look at? Daily or minute? Let's see. Come on, guy. Why is this taking so long? Scrutinizing. Let me look at this shift logic. This is how features are identified. Any column whose name when split by underscore. "30-minute candles. March 31st at 12:30 Eastern Standard Time. There's a spike in price. Mark out the body of that candle." Oh, here. So if I zoom out, I don't have a 5 days and 5 minutes. Oh, here we go. So this will give us 30-minute intervals. Now I look at March 31st at 12:30. Well, there's something wrong with this. It says it's 26 the year. Okay. March 31st at 12:30. There is a spike in price. Mark out the body of that candle. Wait, are you talking about this one? Or 31st at 12:30? This is the data off? Am I looking at the right asset? I'll go off of this one. So what do you mean map out the body? Like mark out the body. Look at how the price has returned to that zone. We must be talking about different things. You said look at ES. So this is ES1. Oh. This guy? Or this guy? $12:30 Eastern time. Oh, so maybe this knows that I'm in Western time. So 12:30 Eastern time would be 9:30 my time on the 31st. Oh no, the market open. Oh. So what's off here? Something's off. Oh, so 12:30 was right? Oh, so there's a, I mean, how do you identify, 12:30 E-mini S&P futures. Yeah, that's right. So how do you know? Is this guy done thinking? Oh, here we go. Calc forward return has no min periods. You're set. Oh. Yeah, it is. I could do, if I had better internet, I could do less of a delay. Let me see, is there a way to do less of a delay? Stream latency. I have it at normal. I could do low late. Yeah, I think to do low latency, I need better internet connection. Because when I've done that before, it drops out. Okay, so I'm set to UTC. So let's do. You're doing Eastern time, right? Yeah. So let's go New York. Okay, March 31st at 12:30. 12:30. This guy? Oh, no. That's the 30th. 12:30. Aha! That was the candle. I finally found it. Okay. So we have a massive spike in price. Okay, so this is the value gap. So this is indicating that this was all buyers. So the buyers and sellers never got to fight it out. And therefore it should return to this price. So that, is that right? Is that concept right? That I think the way I'm understanding it is there's a big spike in price. So the buyers and sellers didn't fight it out. It was all buyers because some big institutions or one bought a bunch of shares at once. So the buyers and sellers didn't get to fight it out. And so it seems like that giant spike drove positive momentum. But at some point when it's high, you know that it's going to come back and test this range between 64.94 and 65.34? Or do you use the open and close of the candle, or I guess you would want to use the high 65.62 and the low, so about $100 gap. The space where the candle is alone, nothing to its left or right, can be considered a fair value gap. Okay, so it should return to this price because the buyers and sellers never got to fight it out. So, but then what is the strategy when you see a big candle like this? You short it immediately, or do you wait to short it? Is there some way of picking out the peak and then you know when to wait to short it, or do you wait till there's a big volume spike down? Like here, big volume, and it went down. So this is indicating that it's getting ready to fall back to test the price here. You need some high volume stuff. The top of today was a hammer down zone where lots of structure above has sent the price down from that area in recent history. So the top would be here. What counts as recent history? Like the last day? I mean, this seems like it's bearish, but I guess, yeah, the S&P is bearish right now. I bought puts. Wait, so how did... Oh, so you used the fact that it's the hammer down? How did you know it was a hammer down? I guess it looked... Yeah, how would you know where that is? Oh, okay, so what's a retracement? Does that just mean drop 66% of the way down to this test region, the fair value gap? Or is that some like line, some sort of line you draw? Um, a 1 day return cross-sectionally z-scored against other stocks full 5 when using a base index or subclass. Panda's defaults min periods equals 1. So do I get the... I want to look at the data set after it computes. So before I split data, this is telling me my 5-day future log returns is incorrect, but I calculated this before and looked at it. So let me put in, before I train the model, let's put the debugger in, and then I can look at the data. So retracement. What I want to know is, how do you determine this is a hammer down zone? So there were big spikes in volume. I mean, doesn't this look like it would be a hammer down zone? Even that, there's only one reference to go off of, and it's the 26th. I mean, obviously, I need to figure out more about this. Cross-sectional z-score computed on the wrong population. Your phase 3 transforms compute CSZ score on DF. The full raw OHLCV data, including all buffer rows and every stock in the file. Then at line 162, you merge back to the universe. This means both your features and your target are z-scored against a much larger population than your universe. Okay, so I need to incorporate these suggestions. But honestly, I'm too tired to keep going for tonight. So thanks for watching, NGK. Thanks for tuning in. I'm going to look more into this because I need to figure out how to get good at this, because this is what my coworker does, and he makes a lot of money doing it. So anyway, that's it for me. Have a good rest of your night. Thanks for tuning in, NGK. Adios. So 12:30 was right? So this. Thanks for watching, NGK. Thanks for tuning in. I'm going to look more into this because I need to figure out how to get good at this because this is what my coworker does, and he makes a lot of money doing it. So, anyway, that's it for me. Have a good rest of your night. Thanks for tuning in.